Hello everyone and welcome back. We are continuing our look here at Unbounded's lesson on multiplying and dividing rational expressions. We already talked about multiplying rational expressions, where you multiply across the top to get your numerator and multiply across the bottom to get the denominator of your answer. Okay. We also don't want to forget about simplifying our results too, either by multiplying everything first and then factoring and simplifying, okay, to get your final answer, or factoring and simplifying first and then multiplying to get your final answer. Again, my recommendation, factor and simplify first, then multiply to get your final answer. Okay, so looking at our division now, looking at division, because that was all multiplication, you'll see here that every division problem we just change into a multiplication problem. So you'll notice here that we're dividing by c over d, and we change that to multiplication by d over c. And that's true in general. Anytime that you had something where you did 2 maybe divided by 1/3, that's really the same thing as doing 2 times 3 over 1, or in other words, it just gives us 6. Okay? So keep that in mind. That's true for rational numbers as well as these rational expressions. So find the quotient, that's the answer to our division problem here, and also reduce to lowest terms. Okay, so let's go ahead and do this. So first I'll change that division to multiplication. So we'll make it times 2x over x minus 2. Okay. Then let's go ahead and factor things. So the only thing that factors here is this numerator, x squared minus 4, which remember, it's the same thing as saying x squared plus 0x minus 4. So we're looking for two numbers that multiply to make -4 and add to make 0. So go ahead, pause the video, and factor it. Okay, hopefully you took the chance there to pause the video and factor, because we're going to then use that and get x minus 2 times x plus 2 over 3x. And we'll multiply by 2x over x minus 2. And now what cancels? The x minus 2's cancel. This x and this x cancel. Okay? And that's pretty much it. So we'll multiply what's left up here, the 2 and the x plus 2. And we'll multiply what's left in the denominator, which is just the 3. Okay? So we could maybe rewrite this as 2/3 x plus 2 like that as well if we wanted to. Either one's acceptable. All right, let's try another problem here. So 4 and 5, why don't you guys go ahead and try 4 at least here, and then we'll talk about 5. Maybe if you want to try 5 as well, you can do that too. But let's at least do 4. So go ahead, give 4 a try, see what you can come up with there. Or get as far as you can, I should say. Okay, so hopefully you pause the video. If not, pause it now. Try it on your own. Remember, change the division, multiplication, factor the numerators and denominators, and then cancel, and then multiply. Okay, hopefully you did that. So let's go ahead. I'm going to do a couple things at once here. First, I'm going to factor this, and so it's going to be x minus 3 and x minus 2 over x plus 4. I'm also going to go ahead and change this division to multiplication. So we'll say times, and I'm going to put this in the numerator, but I'm going to factor it too. So it's going to be x plus 4 and x plus 1 all over x squared minus 9, right? But we know what x squared minus 9 is really like x squared plus 0x minus 9, which means it factors to x minus 3 and x plus 3. Okay? So the x minus 3's cancel, the x plus 4's cancel, and that's all. So we're left with x minus 2 times x plus 1 all over x plus 3. Okay? And there is our factored and reduced problem. Now, number 5, okay, it might look a little bit funky. We have fractions within a bigger fraction right here, right? Fraction in the numerator here, fraction in the denominator, and it's all in one big fraction. So what do we do? Well, remember, this fraction bar here is the same thing as division. So in other words, this is the exact same thing as writing x plus 2 over x squared minus 2x minus 3 divided by x squared minus x minus 6 all over x squared plus 6x plus 5, right? Which then it's just like the previous problem up here. So don't let this scare you too much there, okay? So what can we do? Well, again, we're going to leave this the same. I'll go ahead and factor this denominator too when I rewrite it down here. So I'll put it over here. We'll do x plus 2 over x minus 3, x plus 1. times, now, again, we're going to change this division to multiplication here, right? Which means instead of dividing by this thing, we're going to multiply by the reciprocal. And again, I'm going to go ahead and factor these things too. So this will become the numerator, and it factors to be x plus 5, x plus 5, x plus 1, sorry. And this factors as well. It's going to be the denominator over here, and it factors to be x minus 3 and x plus 2. And now we look for things to cancel, right? So the x plus 1s can cancel out. The x plus 2s can cancel. And that's it. These x minus 3s are on the same, both in the denominator, so they have to stay that way. So we'll leave the x plus 5 there in the numerator, and we can write x minus 3 times x minus 3 in the denominator. If you want to, because we're multiplying the same two things together, you could rewrite that denominator as x minus 3 quantity squared as well. Either one of these is acceptable. Okay? So, in summary, to multiply two rational expressions, multiply the numerators together and multiply the denominators together, then reduce to lowest terms. But remember, I actually say to do reduce first, simplify first, then multiply the numerators and denominators. To divide, we are going to multiply the first by the inverse, okay, or the reciprocal really, multiplicative inverse, which is really the reciprocal, okay, of the second, and reduce to lowest terms. Okay, just like that. So thanks guys, and we'll see you next lesson.